Two 4x4 squares intersect at right angles, bisecting their intersecting sides as shown. The circle's diameter is the segment between the 2 points of intersection. What is the area of the shaded region created by removing the circle from the squares? So you got all that? It's kind of confusing. Well, actually, let's think about what's going on when it's intersecting, because it seems like half the problem is about the intersecting regions. So, well, the parts that's intersecting, well, first of all, we have our two 4x4 squares that kind of tilted like that. And, well, bisecting means cut in half, like two. Bi means two, so two dissecting, kind of cutting it in two. Well, that means the intersecting lines cut the sides of intersection in two. So our two 4x4 squares are going to look something like that. And because they're bisecting sides, that means these two are equal, and so are all of these other side lengths. So, well then, I'm going to insert a circle into that, and then I'm just going to have it go around the whole thing. Okay, so let's think about like what they kind of hinted to us, like removing the circle from the squares. We can first calculate the squares and then remove the circle instead of trying to calculate that kind of funky little archy region. So, well, the two squares, first of all, are both 4x4 squares. So they each have 16 plus 16 area, which is 32. So the area of the two squares together is 32, but of course they intersect and that little square in the middle. Well, if they're bisecting their intersecting sides, and each one of the sides is 4, that means the bisecting sides, like the bisected sides, are each 2. So in that middle is a little 2x2 square, which has an area of 4, and that is 28. So the area of this shape, before we remove the squares, is 20. Before we remove the circles, is 28. So now we have to remove the circle, right? So I'm going to kind of zoom in on that little intersecting point. Draw a little much bigger. And then this is 2x2. And we have a circle whose diameter is the segment between the 2 points of intersection. Well, these two, as well as these two, are the points of intersection. So say we can just find the diameter. So, well, if each of the sides is 2, well, because it's a square, its diagonal, the square's diagonal always cuts the square into two 45, 45, 90-degree triangles. And the rule for those is the hypotenuse, which is the diameter of the circle, is always the square root of 2 times the side length of one of its legs. So here, well, that diameter is 2, the leg, times root 2, and, well, 2 root 2. So if that's the diameter of the circle, well, if you want the area of the circle, you want radius, so you can just divide by 2. The 2's cancel. Now the square root of 2 is the radius. Well, the area for finding a circle is the radius squared times pi. Okay, the radius is root 2. So we square root 2, and then we multiply by pi, is 2 pi. So the area of the circle is 2 pi. We're just taking the original 28 and removing the circle, so minus 2 pi. And we have our answer, 28 minus 2 pi.